like to introduce our next speaker, me. So I'm going to be talking about two different things. One, advancements in the technology for ChatGPT and other large language models that are going to make a big difference and are going to address some of the issues that we've brought up in our conversations up to this point. Then I'm going to be talking about possible applications of that technology that we're going to be exploring this summer. But first, let's take a step back and let's take a look at what the technology is. So this is graphical representation of a decoder transformer. So this is the technology that underpins ChatGPT, GPT-4, Bard, Anthropic's Claude. All of these are decoder transformers. And let's just take a moment to sort of go through and see what's happening here. One is you start with some text, a prompt that has to be turned into numbers. Deep learning networks only use numbers. And so you have token embeddings. That means you identify words or subwords with numbers, and then those get fed into the deep neural network. This is where the issue comes in with, did you have enough forethought and foresight to make sure that your token embeddings supported multiple languages? So that's a problem that GPT-3 got into. It was very English-centric. And so if you try to use ChatGPT-3 right now to do languages other than English, because it is multilingual, in some languages, you're going to be expending 8 tokens to get what would be 1 token in English. And so that means the model is not going to perform as well in languages other than English. It can do it, but it's more expensive for it to compute. And think about trying to tie 8 different tokens together to have a meaning. That's hard. So token embeddings, token embed, sort of a first step. Then you get into this decoder stack. And the decoder stack is actually pretty important. This is actually where most of the representation and most of the learning happens. So in the decoder stack, you have 2 different things in each one of those boxes. One of them is an attentional mechanism, and the other one is a feed-forward network where information is learned and then stored. And then all that information, you have multiple stacks of those, and you get richer and richer representations as you go on. Then you get into hidden states, and then you can make your next word or next token prediction. This is the base model, GPT-3. So on top of that, you do a couple of things. One, if you want the model to be able to do more, you grow it. And what do you grow? You grow primarily those feed-forward networks so it can learn more and represent more. But notice, this is not a database, right? So think of the models learning like a JPEG of the internet or a JPEG of what it's been trained on. It's okay. You can identify some people. Other people are just blurry. So it's not an absolute lookup. So that is a strength because it is representing, but it's also a weakness in that you don't always have facts there. And think about what we're doing here is we're asking the model to produce a reasonable response, a probability. It's making a plausible response. So when we talk about the models hallucinating, in truth, the models are doing exactly what we train them to do. So a weakness of the model. So we can increase the size, we can increase the training corpus size, and that gets us a better, richer representation in the model. But still, it's not really a good model to interact with. If you ask it to do something, please give me a list of books by Zora Neale Hurston. I love Zora Neale Hurston. Then what GPT-3 will say in response is, because I enjoy reading her books and would like to learn more. No, I'm asking you to give me a list of books, not to continue the story of my asking for the books. Well, that's instruction fine-tuning. So that gets us up to the next level. So the model understands texts, understands tasks, and will respond to tasks, but in a very automated kind of way. You ask the question, it gives you the answer. There's no coming back. There's no chat. There's no way to iterate on what you're doing. It's a one-shot deal and you're done. So the next thing we do is reinforcement learning from human feedback. And this allows the model to respond in a way that's more chat-like keep in mind what came before, respond in a helpful way, not respond in a way that it learned on the internet. Think about responses on the internet, especially if you try to correct the model. On the internet, if you point out to someone that they are wrong about something, what kind of response do you usually get? I'm betting it's not helpful, right? And so we do reinforcement learning from human feedback so the model responds helpfully. So even if you say the answer you gave me was incorrect, it doesn't question the qualities of your mother. Instead, what it does is it says, I'm sorry, let me try again. And then we have prompt engineering. And we had a workshop on this yesterday, and that is a lot of how you get what you need to out of the model. But we still have the issues where you have the information which is learned, not a database, and it's not possible to get exact answers with real facts to everything that you ask, because again, it's a JPEG, and it has problems with some types of calculations like math, because again, it's doing probabilistic. So the math is going to be iffy. So what do we do? Well, one thing that we can do, let's putting this into context, is first of all, to do better, we can be more structured on our prompt engineering and be clearer about what we're asking for and how we're asking for it. So that's important. But another critical part is to open up the model to tools. So give the model ability to use tools to either go and seek information, or to do calculations, or to get answers, which are then fed back into the prompt. And then you can get actual veridical information, useful information. So think about if the model were able to reach out and just plug those numbers into a calculator. It represents well what you're trying to do. I want to average these 24 numbers. It knows that, it just can't do the math. But it represents it well, and so it knows absolutely how to put that into a calculator, run the calculator, and then give you the result. So give you an idea of how quickly things are moving. On Friday, OpenAI released plugins. So plugins do exactly this. Plugins allow the model to go out and seek information and to bring it back. You might have experienced a little bit of this with Bing GPT. So Bing GPT was an early version of GPT-4 and did have the ability to do searches. But you'll notice the searches are a little bit limited. It goes to kind of like the first web page, gets what it can, and then comes back. With plugins, you have a much more targeted ability. So you can send it to specific web pages, or you can send it to a service like Wolfram. So Wolfram Alpha. How many people have played with Wolfram Alpha? What has your experience been with it? What did you do with it? Yeah. Do the derivative of, okay, anybody use it for other things other than sort of mathy things? Well, yes. Bill. Oh, so it knows things. So this is a symbolic AI that can absolutely get to information in a database way. So this is not represented. This is actually going out and creating queries against known information. So you can get statistical information, you can get lookups, you can get calculations of calorie counts for meals that you have. So this is a hardcore version of AI where it's actually giving you information and doing calculations for you. So now combine that with the language understanding of GPT, and now, you know, as I say, you're cooking with grease. I'm a vegetarian, but still, I get the idea. So you're really getting someplace because now you can get the answers that you need to have, but in a way that is conversational. And so you can get the idea of what you're trying to do, but actually get the answer. In addition to that, you have other tools that allow you to go after specific documents, say Google documents or documents that you hold someplace as well. So if you're interested in getting answers about against particular documents, so think along the lines of like medical information or medical guidance or your own documents that you might have in a class that you're teaching. So you can actually narrow that field and say, generate questions for my students based on only these documents. Or, as we were developing last summer, building assistive technologies, for example, with folks who are not neurotypical. All right, so starting a job, trying to remember everything that you need to do and keeping track of everything that you need to do can be a very difficult job if you're not neurotypical. So we built an entire system around, and so folks could upload information about their jobs, or a job coach could upload information, and then could text information and say, what time am I supposed to be at work? When do I take lunch? Where am I supposed to go? What bus am I supposed to take? Good answer. That was a lot of work. We spent an entire summer doing it.
Or something. I don't know what would be the best way.
You can do it with the plugin.
Negatively correlated, maybe that's not the best way.
So think about being able to point to your own schedule,
whether it's
point to all of the different syllabi that you have for all the classes if you're a student,
sure how you cut the time windows,
or if you're an instructor, have a syllabus that you can put out and you can say, ask any question that you want. Here's the chatbot that will actually go and get the answer from the syllabus. Again, with a plugin. But things aren't still quite tied all the way together. Because what you need to be able to do is sometimes you need to be able to get the information, maybe you want to have it submitted someplace else. You need to have an entire system that gets pulled together. So you might have multiple models that are working in concert, or you can land answers someplace. And this is where LangChain comes in. So LangChain ties together these different elements and creates full systems out of this. So if you're thinking this is really cool and could be very, very useful, I think you're right. Think about all the things that we want to do when we are teaching. We want to be able to create good quizzes, and the more quizzes, the better. You know, if you want to do low stakes testing, that means you've got to generate a whole bunch of questions, but you want to do it against a particular article that students are reading, chapter of a book, facts that you have collected. Well, now with all of this together, you could conceivably do that. You might even build an interactive agent for your students, and so they could actually experiment. One cool thing I'd love to do is, and Ole, are you still here? I can't. Yeah, you are. So, sort of, you know, talking with Einstein, taking that in that vein. Imagine if you're teaching a philosophy class and you want to have an agent that's going to respond in a particular way, and your job as a student is to guess who you're talking to based on how they answer the questions. Well, I don't know who it is, but it's definitely a nihilist. So this brings up another issue, and that is the digital divide, right? So the folks who know this and the folks who have the resources can build this. And then the students who are the students of the people who have these resources are going to benefit from this. And you're going to have a growing divide, or could have a growing divide, between those that are equipped and those that are not equipped. So one of the projects that we have every summer as part of the Data Science Institute is our Data Science for Social Good. We work with, we hire data science fellows, and we also have last year, and we're continuing this year, collaborating with the Frisk Center for Autism to have fellows from Frisk Center working with this as well, to build solutions to address, to use data science for social good. One of the projects that we're going to be doing this summer is exactly this. So we're going to be doing two things. One, we're going to be helping university faculty. I'm announcing this for the first time here. This is why I've not heard of it yet. We're going to be working to prepare faculty to include AI in their classroom, while at the same time working to address the digital divide. And the idea is this: we're going to be putting out a call for faculty to come to us and to partner with us to develop tools for use in their teaching. So what are some of the things that you would like to be able to do in your classroom using the tools that we were just talking about? Second, we're going to help bridge the digital divide by sharing the resulting tools. Not necessarily the content is the faculty members, but the tools and the approaches being shared through open source to make it easy for other instructors without as many resources to take, put in their own resources, and then be able to use the tools internally as well. So imagine that there's a system that you've built to do really low stakes quizzes, make sure that students have really learned material. All you got to do is you got to break out and take out that back end where the information is, and then that system could be used over and over and over again. So if you're interested, and we'll be advertising this more and talking about this more broadly, but if you're interested in being a partner, you can fill in the form. And we'd love to talk to you about those capabilities and what's possible. Think of this as being the first step among many steps to really using the tools, but using them in the proper way, not trying to get facts and references out of the models, but instead tying them together into an ecosystem that we can depend on and have more assurance in. Let me stop here and take questions that you might have.
Decoder stack. I didn't realize the stack component, is that just the series of layers of encoder decoder?
So the stacks are actually, in this case, it's a decoder only network. And so the stacks are, and I'll make this a little bit bigger. So the stacks here are actually attentional mechanism and feed forward network. That is one stack and a decoder, and you have multiples of those layers. And that's actually the heart of the decoder. It's going to be attentional stack and feed forward and multiple stacks of those. That's the secret sauce.
But the data is actually flowing through it more like a queue.
Yeah, so the data is stored in those feed forward networks. That's where the knowledge is. But yeah, if you're doing just inferencing, and that is just the prompt going in, flowing forward, and then coming out in terms of a next word prediction. All matrix multiplies. This is just regular deep learning, but just a different architecture and a remarkably successful one.
Thank you.
Absolutely. Other questions? And thank you for asking questions. I was thinking, man, am I going to be the only presenter where nobody asked that question? Yes.
So related to your final comment, regarding the developing some class material, I'm wondering, so can you give me some overview how we can develop this kind of tool? So
yeah, so
like a transformer model. So transformer model, we actually have our own data and we fine tune, and to get actually what I want to answer to our scientification. Then this kind of setting, so using the GPT, how we can actually train to get what you want.
So this is a little bit of a different paradigm, right? Everything that we've talked about up to this point, before this introduction of plugins, we've been talking about domain adaptation. So training a model to understand and to absorb the information that you have, which is not a great way to get absolute information. It's a good way for the model to learn concepts about what you're doing. But in order to get useful information that is based only on the facts that you have, that's where the plugins come in. So the model is actually querying against factual information and then using that in the further processing. That combined with prompt engineering can have the model only operate on the information that you're giving it. So you can imagine a prompt such as answer the following question using only the information that you retrieve from Wolfram Alpha. Cite exactly which of the responses from Wolfram Alpha you're using in reporting these results. So does that answer your question? I'm unsure if I did.
So basically, if you want to develop our own tool, so suppose we have some idea, and then is there any way to develop our own tool using existing GPT tool? That's basically I'm asking.
Oh, do you want to do your entire stack from the? Oh, absolutely. So as a matter of fact, we've on the screen that you sort of see back there, which is flashing past, you'll see projects that we've undertaken. One of them was training a BERT model from scratch on medical information data. Another one is we are taking on a couple of projects right now that are going to involve training models from scratch.
Oh, yeah, that kind
Yeah.
of thing I understand. Actually, I'm doing that one.
Mhm.
So I'm basically training the variant of a Baltimore,
Yes, you
for
are.
example,
Yes,
and
yes.
using our own data
Yeah.
to answer to my question,
Yes.
scientific question. And so, but that kind of framework is applicable to the GPT setting. That's basically I'm asking.
So and tell me if I'm still not answering your question, but so the trick and the tricky part here is that training has to take place early. So if you want to create sort of a conversational agent or get that advanced, you have to go through those steps of instruction fine-tuning, reinforcement learning from human feedback, almost certainly. We've seen, Bard before they did a rush job on reinforcement learning feedback, people hated it. It didn't work. And without instruction fine-tuning, it doesn't work at all. However, just about 3 weeks ago, researchers at Stanford released Alpaca. Alpaca was based on a model called Llama. And what they did was they did their instruction fine-tuning by actually using GPT-3. So GPT-3 was providing the training materials to train Alpaca. So what's different about Alpaca? It's much smaller. It is the smallest one is 7 billion parameters, and you can run on a laptop. The larger one is 30 billion parameters, still can run on a beefy laptop or on Colab Pro, and has many of the capabilities of GPT-3, but on several order of magnitude smaller. So in that case, I'm thinking there may very well be some possibility of, training a model, domain adapting or training from scratch, and still getting some useful interaction with it. They did not do, or at least I don't believe that they've done reinforcement learning from human feedback, and I don't know how possible that is with the smaller models. That is something we'll be researching ourselves.
Thank you.
Absolutely, thank you. Oh, and there's one question back here, and then Ben, maybe you, VJ, and then maybe Ben.
Thank you. Excellent overview. So for the GPT-3 to we can do prompt engineering, and with plugins we can kind of narrow down and to what we are seeking from the queries. I was curious, what are still limitations with GPT-4 and where it still struggles or room for more tuning? Because I'm curious, this would grow bigger and bigger in space, I assume, first when the model. I'm not sure how much space it takes, and then for.
So, and I'll answer this question, then I'll answer other questions afterwards since we're at time. But so GPT-4 is somewhat bigger than GPT 3.5. We don't know how much bigger because they did not release very much information on that at all. We know that in many ways it is very capable. It scores 5s on most of the AP exams. It scored 90th percentile on the bar exam. It does coding very well, and we've noticed some difference between coding in GPT 3.5 versus 4. But and they will all have they'll all have the plugins. But I think it's an open question whether you must be that large to get that type of behavior, or whether that is a function of the training. And I don't know if that's known yet. So it's not the case where you must just be getting larger. Alpaca, I think, really raised the question about, is it the quality and the amount of training, or is it the size of the model? And we don't know yet. All right. Thank you all very much for your attention. We're going to take